Crewton Ramone's houseofmath.com.
Crewton Ramone's house of what?
Sure, go ahead.
Crewton Ramone's houseofmath.com.
Alright, give me the Greek alphabet.
Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, c, omicron, pi, rho, sigma, tau, epsilon, pi, psi, omega. C. No, sir.
No, sir. You can give me a sir. I don't care. Either one. Alright, have a seat. Okay, they knew that since about kindergarten is when I first started teaching them because they were learning stuff rote anyway. Since they're learning stuff rote, why not throw the Greek alphabet in there? Why not throw, come here and give me quadratic equation.
Oh.
Come here.
Isn't that this?
What is that?
SOHCAHTOA.
That's SOHCAHTOA. What's this?
A squared plus B squared equals C squared.
What is it? What's the name of it? What's the guy's name?
No.
Pythagoras.
Oh.
Give me the quadratic equation.
A squared plus B squared.
Negative B.
Negative B.
X equals. Get over here. You can't see it.
Oh, I forget that one.
Okay.
Negative B plus.
Plus or minus.
Plus or minus. Oh, dang.
Really? Were you thinking you're going to go back to school over there? Really?
4A.
You thought you were going to go back to public school, didn't you?
Over
2A.
One more time.
B squared. Oh, dang it.
Plus or minus.
Plus or minus
B
C squared minus 4AC all
Alright.
over.
What happened to the square root?
Square root. Oh.
There you go. See? Alright, so that is rote memorization. Negative B plus or minus the square root of B squared minus 4AC all over 2A.
3A is the joke.
And you didn't even get, it's not a joke when you can't even remember the first part. Now, the idea is that if you're going to be teaching them rote memorization, might as well just teach them rote memorization while they're wanting to know rote memorization. What you guys are thinking, and we talked about this earlier, is that, and the point of this is that what we're going to do here is show that, yeah, we're going to combine the two. We are going to use these Pythagorean triples. We're going to start off with small ones. We're going to use this same concept every darn time, where we start off with concepts and the numbers are small, and then we move down to formula. We're not going to give them formula to memorize and then give examples. We're going to give them concepts, and then they're going to get lots of examples, and then they'll be able to come up with their own formulas over time. And as time goes by, the numbers get bigger and more complex. So we start off, like say we're going to do Pythagorean theorem, start off with a nice small one that works out nice and evenly, and then work up to bigger ones. But we're still just going to use these guys, because you know what? These are the ones that they're going to find on tests. So we're going to talk about the steps or the actions that it takes and degree of difficulty. The fewer steps, the lower the degree of difficulty. The more steps, the higher the degree of difficulty. Alright, it's not about the numbers. The concepts are all basic. The concepts are this one plus that one is the same as that one. That's the basic concept. Now, when I'm counting one like this is an easier one than this one, just because counting to 9 and counting to 16 and counting to 25 is a whole lot easier than counting all the way to, 625 or 49 or whatever it is.
Or 576.
Right, or 576, exactly. But that's why we spend time working with the square numbers up to 20. And actually square numbers up to 25. And then fooling around with square numbers like this, so that later on when we come back to this, we're not fumbling around with computation while we're trying to do concepts. Do you get it? So the idea is that we want them to understand the concepts, and computation is, that's why I put that on your board there at Arithmophobia No More. Why do you need to know 7 plus 8 to be able to solve x squared 3x plus 2? You don't. They're not related. And in fact, x squared 3x and 2 is easier than solving 7 plus 8. Because it's fewer steps. Okay. Now, And we'll get, and like I said, we're gonna get to that. We're gonna get to that. Like really, we're gonna drill down and talk about that in just a second.
Are we gonna do it?
So now let's talk about this. The very definitions we need to know, right? Where is Mui? What'd you guys do with Mui again?
You just had him yesterday.
I just had him. He was right there. What'd you do with Mui?
Where'd he go?
Where'd he go?
Movie ran
Mui
away.
ran away again. Oh, here he is.
Okay.
Alright, we got him.
Back up there.
All right.
Movie
So Mui, your puppets. Some of you guys are finding out the puppets are actually kind of fun.
Yeah.
Right? Sokatoa, hey, hey. Sokatoa, hey, hey. Sokatoa, hey, hey. Sokatoa, hey, hey. Sokatoa. All right. So, Sokatoa. They get to know Sokatoa. That's the first thing. Knowing Sokatoa. What does that mean? What does the Sokatoa mean? What the Sokatoa means,
I know
the
what so means.
definitions for these guys.
I know it's over.
All right, so these are actually easier again than adding, say, what is 6 and 7?
15.
13. Had to think about it for a second.
Yeah, quick second.
What do I need? What am I doing here? Tell me about 6 and 7 being 13.
You're trying to take 3 from
What? Okay, either one. Do it. Be fast.
3 from 6.
3 from
and
6.
10 for the 7. And then.
All right, so you did it this way. You took the 7, took the 3 out of the 6, and there's 3 left.
I
You
did
could do it the other
opposite
way.
I
You could
did
do
the
6
opposite
takes the
way.
4 out,
That's
and
what
there's
I
3
did.
left. Okay, that's still more than having to just know. What does sign stand for?
Sign.
Opposite
over
over
hypotenuse. I have that memorized.
I don't need to be 16 to be able to do that.
Hmm?
I can be 3 to know that. What does cow mean? Well, that means an animal with 4 legs that goes moo and it eats grass and stuff. What does chair mean? Oh, that's not an animal, but it has 4 legs and you sit on it. Same thing here. There's no way to get them, right? This is the definition. That's what the word means. So you're giving them definitions. Just like when we learn any language, got to know what the words mean. Hola, that means hello. You don't say hello in Spanish, you say hola. Right? Buenos dias, that means good day. That also means good morning. That's also a greeting. Right? You got to know what the words mean. Buenos, that means good. Dias, that means day. Got to know what the words mean. Sign, that means opposite over hypotenuse. That's what this is. Okay, and I'm just using this for an example. Right? We're not just going to do trig today, but I mean just as an example. So they got to know what it means. Okay, cosine, what does cosine mean?
Cosine.
Adjacent over hypotenuse.
Adjacent over hypotenuse is the correct, right? There it is. Right? It's just like when we first start talking about doing multiplication. 4, 8, 12, 16.
20.
When they first knew 4, 8, 12, 16, they didn't know 16 was 4 fours. They'd only heard 4, 8, 12, 16. They'd heard the patterns. You add that information later. But first it's just the patterning. 4, 8, 12, 16, 20, 24, 28, 32. How many 4s in 28?
7.
Good job. Right? They know that now. When they were 5, that was just 28 was just the one that comes after 24 and before 32 in the song. Are you following me? Okay. So you add that knowledge later. When you're first starting out, what we're doing is just the concept. These are skip counts. This is the pattern. This is how it works. Right? Okay. Now, when I first start off with one like this is a whole lot of steps. Oh my gosh, when I'm 4 years old, that's a lot of counting. I gotta count 1, 2, 3, 4, 5, 6. Even though I know this one's name is 6, it's very rare to meet a 4-year-old that just goes 6, 7, 8, 9, 10. So what are we doing? We're collapsing time frames. We're knocking down steps. Right? That's what the computation is. Okay, computation should be a wholly different thing. Here is computation, here is concepts. So compute concepts. What we're trying to do is make that fast and easy. And we've fallen down where we don't even have these guys being able to do computation anymore. Got these kids that are in 7th, 8th grade that can barely add numbers together. Graduate from high school, can't subtract, can't make change. Common Core guys start telling you about counting up, and they show you how to count up, and the people are in an uproar. when that used to be a common skill. Any person that graduated high school in this country in 1950 could make change. And then McDonald's had to put, pictures on their cash registers because the kids couldn't make change. I'm not even sure you guys can make change that way. I mean, they can subtract, but I mean, if I want to do 65, say I have $1.65 and I paid with $2, can you count up?
You have to have 35 cents.
Okay, so that's what I mean. So you count up. You give them a nickel. Now we're at 65, 70, right? Then you could give them what? Another nickel, or you could give them a dime, and you'd be at 75, and then you give them a quarter, and now you've made your change, right? But 65, and then you give them another nickel. 75, and then you give them a quarter, $1. That used to be a common skill that any child, any kid graduating high school in the 50s in this country had. That is gone. That has been erased. That's why we started with subtraction. Because, like I said, Jerry caved in. I could have started with division. I could have started with an algebra book. But I gave you the subtraction book because, one, that was stuck in my craw the most. Because out of all the system, that's the one thing that needed to change. Right? It's my one contribution. Because if you look at the smiley face books, they do it the wrong way. You look at the subtraction book, they do it the wrong way. You look at the Series A subtraction book, they do it the wrong way. Right? So what I wanted to do is change that. But the bottom line being is that we got to get the computation mastered first. Okay? But that computation is not how we do okay, and even as soon as I say that, it's not first, it's at the same time. But you're doing the computation, you start with a small computation, you get higher and higher. Right? Right now, these boys have their multiplication tables down pretty well through 9. Pretty good through 12. Some of it through the teens, but they're going to have them all mastered 20 by 20 by the time it's done. Right? If I asked you, let's just ask, what is 17 7 times?
Oh, what's it?
119.
100 and what?
19.
All right. Saying it should be memorized. So you were doing computation. You were definitely doing computation. All right. And what did you do? You did 70 and 49. Why 70 and 49? There's the action right there. That's why we do the add-ins.
I just had to take the 10.
Sit down. All right. How would you get 109 when you got a 4 and a 7?
Yeah.
Yeah. All right. But that's why we do the add-ins. And there again is why. How old are you? 8. See, now for me, on my standards, that is atrocious. In a public school, it's like, oh, well, he's only 8. Nonsense. Because it's going to take us a long time. By the time they get 12, 13, 14, they should have what's currently in the curriculum mastered. And I'm talking about calculus, the whole 9 yards, by the time they're 12 or 13. Because now we're going to spend time doing analysis. There is the mathematics and the calculus, speaking the language of it, right? Understanding more profoundly the algebra and being able to do analysis, statistical thinking. Being able to take large data sets, being able to take large amounts of information, crunch it, and see the patterns. That's the point of this. Okay, it's not, but you can get a long ways just being able, just taking these kids and getting to the point where they can do your basic ops, addition, subtraction, multiplication, and division well. You've done your job. You've done well. That's better than what they're doing now in school. But what we need to do is get to the point where now we can take this and apply it to the concepts. So again, here we are fooling around with just basic concepts. This is going to be critical thinking, and I want you to see that this is already 6 steps and 7 more steps. Then we're going to break it down into 1 step. Hopefully they just identify, well, what's this one's name? 6. And again, this is something you got to work on. They're not just going to pick this up automatically. Right? Okay, let's start at 6 instead of counting from 1, 2, because they're always going to want to start from here. All my little boys, these things, that they want to start from here. Even though they know this one's name is 6, they want to start 1, 2, 3, no, start 6. Then I can go 7, 8, 9, 10, 11, 12, 13. 7 more steps. Over here, this is why my sons told me that they like the trig easier, because look, over here, all I got to know is opposite and hypotenuse. My question is finished. I answered the question. I'm done.
Not to do it though.
That's it. Don't have to do 7 steps. Just gotta know opposite or hypotenuse. That's it. Gotta know the definition. I have succeeded. Yay! Right? Okay, tangent. What's tangent?
Opposite or adjacent.
Okay. Alright. Now.
God.
Now we've done it just in general and we're the little kids and I don't care. That's it, right? We're over here. Alright, get these guys out of here. Alright, so because I know that you guys are just mystified by my nonsense.
We're not in college yet, so we don't know what you're talking about 100%.
Eh.
Oh God, yeah. That's your excuse.
This peanut gallery needs to pipe down.
I'm
Or you're gonna
I'm not
find you're
really
gonna
sure.
learn the definition of what happens when you make a little too much noise. It's gonna be that same thing in when what is it when the sergeant at arms comes with the pepper spray? Don't tase me, bro. All right. So here we are. This is where we are. We are there. The broad concept, the definition of the words. I don't even know the numbers. I don't care about the numbers. I don't need to know what 7 plus 8 is. I don't need to be able to write stuff down. I don't need to be able to divide. I don't need to know about fractions. I don't need to know anything. I need to know that the opposite over the hypotenuse is, and you know what? I'm going to learn some fractions this way. Right? I'm going to learn about some relationships this way. What have we done? We have taken, what are the 5 basic concepts again? 5 basic concepts. Math's the study of numbers. All we do with numbers is count. Highest number we count to is 9. We only count stuff that's same. Right? Rectangles facilitate counting. Those are the first 3. And then 0 and then 1. So we're still fooling around over here, and what we've done is we've taken this and we've cut it in half and we've made a triangle, and now we're going to study the relationships in a triangle. Woohoo! Like it's hard. Okay. So now we can get more, you know, like I said, I could have been doing division, we could have been doing, I've just decided to do trig just because. Okay, we could have been doing algebra. Okay, you're going to need algebra to do trig, but I mean, okay, so we're still in the basics here. Now, what's the next thing? Let's fool around with some Pythagorean triples. Using these Pythagorean triples, and again, if you've got all kinds of time, if you're teaching math for money, you don't have all kinds of time. But I've done seminars where we gave them 3, 4, 5, and we fooled around and gave them, while we were doing lessons and while we were doing other stuff, between breakfast and lunch, their job was to see if they could come up with some more Pythagorean triples on their own. They will usually get these 4. They will come up with some other ones that will surprise you, I'm sure, if you give them time. Don't just tell them, oh, 5, 12, 13 is a Pythagorean triple. See if you can get them to understand it. They're never, or see if you can get them to tell you this. They're never going to get there, though, if they can't square numbers. So if it's little kids, this is not an exercise for little kids. But this is an exercise that would be for like you guys, or for older students, or for kids that can square numbers. And then we can start talking about doubling these numbers. We're going to learn all kinds of math with just these 4 sets of numbers right here. Observe. What is, double this for me, would you?
6.
What's that?
8.
What's that?
10.
Super easy to double, aren't they? Right? You see, for little kids, for them, this is way simple for them. But for the little kids, oh, now we're doubling some numbers. Now we're getting some multiplication done, right? 2 times table. Okay, so now I can see, oh, and there's a relationship that this would be 6, this would be twice as big, and we're just talking about it. You would build these. So this would be a 6, this would be an 8, that would be a 10. Oh, bigger is funner. Okay, now we can do it again. Could you triple that? What's that going to be?
9.
Then what?
16. I mean,
Really?
No, 12. He was thinking.
All right, so before you run your mouth, right, put your brain in gear. What's next?
15.
All right. This one, double it.
16.
And?
30.
30.
And?
34.
See, there's a little more work, right? Ah, we're still just doubling numbers, though. How about this one?
10.
And?
24.
And?
26.
There you go, right? So really, it's doubling 17 was harder. What about this one?
14.
14.
And?
48.
And?
50.
There you go. Okay, and we build these. Build them! Or draw pictures of them. Don't just talk about it. This is training, so we're just doing it, and I don't feel like putting these up on the board. Spending all the time it takes. You guys, when you're working with your kids, you're not just talking about it, you're building them. Hey, make this 8, 15, 17, and I'm talking about getting the blocks out, get an 8 out, a 10 and a 5, and a 17. Oh, let's make it twice as big. Because it's fun! And then let's count it. Because it's fun! Alright, so then you're gonna square these guys. Square that one.
9.
Oh, there it is. Square that one.
16.
Then square that one.
25.
Alright. Now, what if I wanted to square it and I have the bigger numbers? So now I'm going to do the next one I have here. If I got room, yeah, I got room here. Alright, is 6, 8, and 10. Square that one. What do I get?
36.
What do I get?
64.
64.
What do I get?
100.
100.
Okay, so what's 36 plus 64?
100.
100. Good job. Right? I have to tell you, it's a ringer, because yesterday they didn't get these quite so easy. But we only did this lesson
Practice
once,
it
and we did it
once.
for 15 minutes. That's it.
And that reminds
But
me.
they've seen it before in the past. And this is another thing. 3, right? The 3. First time they see it, oh my God, it's new. Second time they see it, oh, we've already seen that. Third time they see it, this is the result. You see it? Okay, now you're going to need multiple exposures to get to this point, and play with blocks and do other stuff. But this is what I'm saying. Third exposure, they're comfortable with it. Now, what happens when they go take a test and they've never seen it before? Panic. That's what happens. And then they will fail other parts of the test because they're so freaked out about this part of the test that they've never seen, that when they wind up taking the rest of the test, then they wind up getting an F. Because they're, again, as I've said in other trainings, the reptilian brain is kicked in, the prefrontal cortex has been shut down, and they can no longer think clearly because they're panicked because they got something that they weren't exposed to. So what you want to do is expose your children to a wide array of mathematics at an early age. It's just like you take your kids to the art museum. Your kids are finger painting. They can barely hold a brush. You still take them to the art museum to go see Monet and to go see Rembrandt and to go see these other guys because you want them exposed to this kind of stuff. It's the same thing with the mathematics. Right? You just expose it to them. What we're doing is educating. Put all this stuff in, preferably before the age of 7 years old. And then later on, what you're going to do is educate. Right? Not cram in, not memorize, not worksheets until they're sick. Right? Give them exposures, play, fun stuff, and then you can educate, you can pull it out later. And they're going to have happy associations with it. Alright, so now, and again, more math. You can do this with all of these guys. Alright, what's this one? This is going to be 10, 24, and 26. What's 10 squared?
100.
Good job. What's 24 squared?
576.
Are you sure?
Yes.
I got a problem.
Father, that's that
You think it's going to be 576? 576. What's 26 squared then? You telling me that 26 squared is 676? Find out. Draw a picture. Do something. Give me an answer.
26.
26 squared. I'll leave that up to the peanut gallery too. You guys, no calculators. You guys don't get to use calculators.
Yeah.
Pencil and paper, you can draw it. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.
556.
1, 2, 3, 4, 5, 6. They better add up, or it's not a Pythagorean triple. And we know it's a Pythagorean triple because I took it right off of there. So you better start doing some math, son. Really, you're going to try and do math with no pencil? Nothing.
Do I have a pencil?
All right. So let's see here. That would be 400. I'm just going to add them up. Look, 400. There's that, right? And then what? That's 60 and 60 is 120? Isn't it 120 twice? Wouldn't that be 240? And then in the corner is going to be how much?
36.
36. So how much is that going to be?
276.
How much?
676.
676. Isn't 100 and that going to be 676?
Yes.
All right. Like I said, see how much math is going on there? Just playing with squares. Just fooling around. That's the computation. That's not the concept, that's computation. Are you seeing the difference? Some of you guys need to turn your cameras on so I can take a look and see if you, I gotta be able to see your faces, like Jubilee, or Christina and Anna. Because all I see is yellow, your little icons, and then I can't tell if you're paying attention, or, well, not paying attention, but if you're understanding me or not.
Or you're using calculators.
Oh, they can use calculators
I'm
too.
understanding.
Okay,
I want to
but I mean, like I said, I just got to be able to see your face. Never let
But I'm sort of sleeping listening today because I'm not.
Yeah, there you go. So, and then same thing with you, Christina. You, and then how do you say your name? Zorro? So I'm gonna call you from now on. I'm just gonna call you Zorro. He's all wearing a hood.
Sorry. It's really funny. I remember my graduation, they called me Oreo in front of everyone.
Oreo?
It was really embarrassing. Oreo cookie.
What is it?
So, yes, some people call me Exorio, and yeah.
But what is it actually? What do you prefer to be called?
It's Haria.
Halia. Spelled Halia, spelled Z-X-O-R-I-Y-O.
Yeah, that makes perfect sense.
Yeah, I'm from Somalia, so in my language, that's how they write the X stands for H.
Really?
Yeah, so if you see an X and they're Somalian, they definitely pronounce it as H.
Okay, so
Haria.
Halia.
Haria.
Khalil. All right. In a
You
million
say Khalil.
years, I never would have got that.
No.
Just call me Haria.
Here we
All
are.
right, I can do Khalil. Is okay. It's just that I never would have got it with an X and an O and an R and an I and a Y and an O. Is all it is.
Oreo.
So,
Halia.
I like Zorro personally. I like everyone just call me Zorro. Zorro.
Christina.
You're being
Or
England.
you
And
can just call me Oreo cookie.
you'll be running around doing math and wow, Christina checked out. She's like, I'm not turning my camera on. I'm out of here. All right, so I think something happened with her connection again.
Okay, Oreo.
All right, so wait a second. Let me invite her back one more time.
Oh, she crashed?
I think she crashed. She may have crashed.
That's
We'll do it one more
Crash
time.
timber.
All right.
I never would have guessed
So yeah, I know. I never would have got that either.
Halia.
It's awesome.
It smells like Zoreo.
Okay,
that.
so
Write that down.
I don't
now.
want to see you sitting here today. That's why I'm keeping the camera off.
Yeah. All right. It's fine. Just making sure, because I'm talking to the crowd here, and it's like you get blank stares. You can't tell whether people are following you or not. All right.
I'm
So
still here.
all right. So the idea is that we have these definitions. Now we're going to start adding more information to these definitions. So over here, we got to know what else do we need to know? We'll have to know about this thing called theta, which is why we started off this thing with the Greek alphabet. What does theta mean? Well, it's like x. If I'm talking about angles and so on, and don't forget to turn your microphone off again, Halia.
Haria.
Haria.
Dang it.
Haria. But it's an O at the end, so shouldn't it be an A? I mean, shouldn't it be O? Hario?
That's how my mom spelled it because it's small. Yes, but if you want to do it in the Swedish way, I grew up in Sweden. They used to call me Haria.
Yeah. Because you're a girl.
Let's leave my name alone.
Okay, fine.
Yes, but in my language, that's how it's spelled.
All right.
I'll just leave that.
We'll just code name Zorro. That's it. Like there's Cheetah Boy and Rooster Boy, and you can be Zorro. Okay, so
Perfect.
so
Well, he's Crewton Ramone.
open capture. All right. All right. So now we've got these guys over here, and now I've got this one, and I got to talk about. Okay, this doesn't mean anything unless I know what angle I'm looking from. Now, if I use theta. Theta means that if I'm talking about theta, that means I'm talking about the same angle every time. And I can use phi, or I can use some other symbol over here, and that means I'm talking about that angle. But if I'm talking about theta, and that should be this actually, theta, then that means that I'm looking from this angle, and I'm talking about opposite over hypotenuse. I'm looking from this angle, I'm talking about adjacent over hypotenuse. The relationship between this and that. Tangent. Opposite over adjacent, the relationship between this and that. But I'm always looking from that angle. Okay, so that theta tells me that I'm looking from the same place. Alright, so now I've got my little theta sign over here, looks like an eye, and I've got my rectangle. Now, or excuse me, my triangle, my Pythagorean triple that I've made here. Now, if I start off with this, and I say I have a sine of opposite over hypotenuse. Okay, so sine is opposite over hypotenuse. So on this one, oh, somebody's having a bad day. We're doing math, and they're having a bad day. All right, so if I tell you that sine is 3 over 4 on this one, in fact, you know what, you're going to tell me. Sine is 3 over 4 on this one, right? What's cosine on this one?
Cosine would be. Hey!
What is it?
Cosine is adjacent.
What's adjacent?
4.
Uh-huh.
Wait,
Over
sine.
what?
This is wrong then.
Ah.
5.
Ah, good job. So then what's that?
Then that is 5.
Good. Now, what's this?
That one's 3 over 4.
3 over. This one's the 3 over 4.
Uh-huh.
This one's
Okay.
messed up.
All right. No, that one's correct now, isn't it?
Yeah.
Isn't it opposite over
Were
hypotenuse?
you trying to do that?
All right. I'll never tell.
No.
All right. So,
I'll take my book
now.
and take my book. I have things.
Okay, so now,
Wait.
if I know this, then I can say, all right, look, I know that sine is 3 over 5 if I draw my little triangle and this is my theta. And I can pick any side, by the way. I don't have to go this way. And that's another thing I have a problem with textbooks. We read left to right. Why not draw your triangles like that? Put the right here instead of over here because we read this way. But that's a minor detail. But this is something just for presentation purposes for you guys where that is actually kind of important. Rather than drawing it like this, draw it like this and make that your theta. It's a minor little detail, right? If this is 30 degrees, this is going to be 1, that's going to be 2. And then I should know what that is because that's a special triangle. But we'll get there and see if we can get these little runs to do it. All right. So instead of having it like this, the 3 and the 5, it's just easier to see if you draw your triangle pointing left to right. Okay. Like I said, that's a totally minor little detail, but I'm telling you, that makes a huge difference with kids. All right. Right there. There's a little nugget that you won't get elsewhere. All right. So now, if I tell you 3, 5, what does that side have to be?
4.
Has to be 4. Now, if I don't know about this, and I was taught flying blind, and I haven't seen triangles, then I could use formulas where I take this squared, take away 9, and get 16, and then take the square root of 16 and get 4, and that's how I know when to put 4 there. So if I say, I have a problem, sine theta equals 3 over 5, then cosine equals x over 5. Well, if I don't know about my Pythagorean triples and I don't know about, then I got to do a lot of work to put a 4 there. if I know about my Pythagorean triples, then I can just draw, well, if that's 3, that's 5, that's got to be 4. You see where concept-based teaching makes it look like magic and is fast and easy, because I understand the concepts and I understand, I've had some experience with numbers before. And guess what? On the SATs and the tests, it's going to be, usually it's going to be one of these 4 Pythagorean triples or a multiple thereof.
Got it.
So now, watch how fast and easy this becomes. I'll put these guys in. And I'll let you guys do it, just for fun. So there's my theta, there's my theta. And you know what, let's make this triangle nicer.
So which one?
And now you see we've done some examples now. We've come down. We've done a few more. The numbers are getting a little bit bigger. See where we are? Okay. So now I say I've got this. And we have let's do what does that have to be? Oops, I did it wrong. I did it wrong.
Yeah, I had a feeling you didn't wrong.
What does that have to be?
8 divided by 34. So we're using this one.
Are we?
Right. Let me check.
See? Now just watch. Just watch. Which one of those 4 are we using? So what does this side have to be?
Has to be 34, 16.
So what's that side got to be? Is what I'm saying. Benazea.
16. So that has to be the 30.
That has to be the 30. Did you have to do computation?
No. I always just remember the concept double that.
That's double that. There you go. Done.
Remember
Don't have to take 34 and square it. Minus 16 squared. Take the square root of that to get 30. Which would have been, right? And that number would have been 900. Because I know my Pythagorean triples and I can recognize them. So now even further, I can say, well, if I have sine, this is 16 to 34. Right?
You're not a monkey.
Then I tell you this is also 34. Oops. Finding this should be easy. What's x got to be on that one?
X. Wait, let me look at my other notes.
Has to be 30.
Has to be 30.
Has to be.
30.
Has to be, because I told you the 2 other sides, all you're doing is finding the other side. Suddenly this stuff's easy. There's nothing hard about this.
Remember.
That kid's 8 years old. I got high school kids crying about this. I got college people telling me that they're never going to get their degree because of this. Are you kidding me? Alright, so then what's tan going to be of this one? Knowing this and this, what's tan got to be?
16 over 30.
Done.
I'm writing this down. Yeah. Good job.
Oh look, they're able to find x and y. So if I said, I know this, now this one, then this.
What is this supposed to be?
Oh, oops.
I
I made a mistake.
Yeah, what I can't
I make a mistake.
read that.
Because I'm gonna make the x has got to be the same, right?
And this is the Y. This is a Y.
See?
That is the Y on top, right?
Yes.
Yeah, okay.
So I'm guessing Y is the upright.
Yes. So anyway, what's it got to be?
So then X.
It's the same problem we just did a second ago. What's that got to be?
Oh my God! I think I can do this just in my notes.
You don't even need your notes. Just look over here.
Opposite.
If this is 16 and 30, what does x got to be? We just did it a second ago. It's the same exact problem we did 2 seconds
It
ago.
has to be 30. Has to be 30.
Has to be 30. What do these two have to be? Well then, if x is 30, I know that x is 30, because in a problem, if you see a series of problems,
16.
x has to be the same thing every
It's a
time, right?
16.
That's why I
I
changed it
thought we were
around.
doing that one, not that one.
Alright, then what does y gotta be?
16.
16.
Y's gotta be the 16.
Oh, this is so much easier now.
How hard is this stuff?
Pretty easy now that I
Love
know
you,
what I'm
kid.
doing.
Right? There you go. Can any little kid do this?
Yes.
Do they have to have gone through a year of fractions before they can do this?
No.
Do they have to have gone through a year of algebra before they can do this?
No.
Do they have to have been able to even add and subtract numbers before they can do this?
No.
No.
They just need to know.
Concept-based teaching. Understanding the concepts, not memorizing formula. Not being, they didn't have to be able to take this squared, subtract this, and then take a square root. All I did is know the basics, understand the basic definitions, I can start speaking the language. Questions?
Yeah. Is Anna still here?
No questions. All right.
Really?
No, Anna's still here.
Okay.
Christina left, I think, is the one that's gone. If you got a question, you ask the question.
Ask the question.
I do have a question. Your oldest boy is 8?
The oldest boy is 10. The younger boy is 8.
The youngest boy is 8.
Yeah.
Right here. He's like, yeah. Yep, that's
Yes. You guys are, I'm impressed by what you guys can do.
me. Yeah, see?
I'm impressed by what you guys can do.
Yeah. All right.
Yeah.
Now, any kid can do this. I'm telling you. Any of your kids can do this. Your sped kids, your kid, right? And once they can do this, oh, now you build their self-esteem. Now you turn that switch on. Oh, I can do math. Oh, this stuff isn't hard. You don't have to explain to them that of course it's not hard, that the degree of difficulty here is less than adding numbers together. You don't have to do any of that. You don't need to mention that at all. But when we talk about degree of difficulty, it's the number of steps. Now this is just critical thinking and being able to do it. So let's do another one, and then I'm going to erase all of this, and you can see how simple is this stuff? How easy is this stuff? And we've turned it into this crazy hard thing that, oh, it's got to be this, and you got to have all these prerequisites, and oh, you got to be able to do that. No. My short answer is
What would you
no.
recommend? Sorry.
Go ahead.
What would you recommend to introduce this thing cos and tan?
Make a
At what point?
when they're 4 or 3 or 4. What? When would you start showing them what a cow is? What's that thing on your head called?
A scarf.
There you go. All right. So when would you think it would be a good idea to tell them what the name of that thing is?
Sorry?
I said, when would it be a good time to tell them what the name of that thing is?
Oh. Okay. I understand.
All right.
You just introduce it whenever.
Whenever.
You just go along. Okay.
Yep. All this is vocabulary. What little kids want to know about the world around them. All this is a definition. What does that mean? That means the opposite of it. When we're talking sine, what does that mean? And you know what? Most guys don't know. Sine 30 is 1/2. That's all they know. They don't understand that sine 30 degrees is talking about a very specific. Now we're getting very specific. We're talking about a 30-degree rectangle. It's not going to be this. This is going to be 5. This is going to be 10. Right? So if I got sine 30, this is 5 to 10, which is exactly 1/2. But again, that is wrong but true. If all I know is sine 30 is 0.5, I have missed quite a bit of the mathematics, wouldn't you say? Let's go back to theta.
Well, I know what I'll be working on Monday.
There you go. And you can do this with any age kid. Just start at the beginning. Start at the basics. Start small. You don't want to start over here, and you certainly don't want to start with numbers that are crazy, that are, you know, square roots and decimals and stuff like that.
Start with the easy stuff.
But once we do these, then we can do any of those. Right? Once I know on a 30-degree angle, and then that's the thing, just baby step you right there. So now I know sine, and I'm going to use, I don't know, let's use this one. Sine is 5 and 13. So, oh, well, that's no fun. In fact, these kids were telling me it would be more fun if you didn't tell us what it was. So then this is going to be, so if this is 5 over 13, that means, here, take this pen, label that triangle. Sine is 5 over 13. Where does the 5 go? Where does the 13 go?
Please do not take this away.
Just do it. Be fast.
Sine is
Where does the 5 go?
5.
Yeah.
13.
5, 15.
Alright, so then where would the 12 go then? If that's 5 and that's 13, what's the other side have to be?
12.
Can it be anything else?
No. Yeah, I was thinking about straightening that up to
Oh my god, anytime.
12, 12.
Fine job. Now, if I have tangent then, if I know 5 and 13, they're already giving you too much information. What's tangent going to be then?
The tangent?
Of this one.
12.
Really, tangent equals 12.
5 over.
Oh, 5 over 12.
There you go. So if they give you this, I mean, why is that hard? Or if they did this, why would that be hard?
5
You know both of them if you know that one.
But then,
There's not even a question there when you get right down to it.
But then there just has to be the one left.
Are you guys with me? Alright. So the last one, what's cosine then?
12 over. 12 over 13.
Done. And all I knew was that. So a lot of times what they'll do is they'll do this, right? Give me the x there. Well, if you know 5 over 13 and 13, then now it's no longer a mystery. Well, if you don't understand the concept, this is all hard. If you forget the concept, basically, you could still do it if you knew it. Now, if I know what I'm doing, I can understand, well, a squared plus b squared equals c squared. But even then, this is of no help if you don't understand the concepts. That I have to take 13 and square it and get 169, subtract 25, get 144, and then take the square root of 144, and that's how I get my 12. Now, if all I have memorized is that that's how to find x, is that I use this formula. I take, like, because here's what x equals when you get right down to it. X equals c squared minus a squared, which is going to give me b squared. And then I got to take the square root of b squared. But I guarantee you that formula does not help. I guarantee it. I see it in textbooks all the time. Doesn't help at all. Because they don't understand the concept. So what gives the formula? Now, when I get down further enough and I've got enough examples, and I've done through these, now this makes sense.
I forgot all about the top stuff that we were doing.
Yeah, go ahead.
Oh, perfect.
Sonia, you gotta turn your mic on though, or I can't hear anything. You can talk all day long, but you gotta turn that mic on.
Well, I keep raising my hand. I didn't want to interrupt. All right, so I'm introducing this to, say, a 4-year-old.
Yes.
Right, so the first time, because you have to talk to me like I'm dumb.
All right.
I'm introducing it the first time, and I don't want to shove too much information down. So the first, say, 5-6 times I played this, right? What part am I introducing?
All you do is the definitions. Opposite over hypotenuse. Sokotoa, Sokotoa, hey, hey. That's it. That's it. Don't need numbers. Just knowing what the sides of the triangles are and the relationships. No, that's a good question. Second time, nice and small. Or maybe the third time. Maybe the fourth time. And I mean, like that lesson I just gave you, the opposite over hypotenuse, the Sokotoa, Sokotoa, hey, hey. The first time you do it, you might just do this. Just get that chant down. That's all they ever heard. And then the next time, they draw a picture. And they can see that this is opposite hypotenuse as in relationship to this. You'll see that on my Trig page, on the introduction entry page to the Trig page. There's a lesson down there. And that's it. That's all we did. Right? Is we drew the triangles, we talked about opposite, and that was it. That was it for the day. We didn't do any math, quote unquote math. We just got the definitions down.
Okay.
Got it?
Yep.
Next degree of difficulty, the next step would be to start labeling a triangle where they know what the numbers are. The next step would be to play a game to figure out if they can figure out what side is what. That we were just doing just now. Right? And this is the beautiful thing about the mathematics. Sit down and be quiet. Oh. Alright, so. Oh my god. Anyway, you guys crack me up.
And I'm just going to say one word.
What?
Boys.
Yeah, boys.
Boys.
They are definitely boys.
They're boys.
Alright, so see, and that's the thing, is that my hand is firmer than their mother's hand, and it works. And I see.
It has nothing to do with the firm hand.
Yes, it absolutely has to do with
testosterone in the body.
There, that too, but it absolutely has to do with the firm hand because they understand that if they don't comply, there's consequence. That's usually instant and has sensation to it. Therefore, I don't have to.
I'm just letting you know that I spank pretty hard. And I use ping pong paddles to not leave marks, because they don't leave marks unless you really hit hard.
Yeah.
I
So
mean,
never ever use anything other than my hand. Never use any other thing but my hand. Anyway, okay.
No, it puffs blood vessels. You gotta use.
Yes, that's what I mean. Just your hand. Anyway, so the idea here is that's lesson number one. Just opposite hypotenuse. Just not SOHCAHTOA. Then we can add some. Then we can get bigger numbers. Then we can get crazy past this. Then we can start getting, and I'm not going to go there now because I want to go elsewhere. But then we can start getting into very specific angles. What's going on at 30 degrees? What's going on at 45 degrees? What's going on at 60 degrees? Okay, those are the known ones in the special triangles. 30, 60, 90s, 45, 45, 90. That would be your next step. Then, after we get those guys, now we can start talking about 20 degrees and 25 degrees and 36 degrees and so forth. Right? Now it's totally easy because I understand the basic concepts. What do textbooks do? Dive in right at, sine 46 degrees is. You see what I'm saying? You see the difference? All right.
That makes a lot of sense.
Okay. Are we happy? Should we take a short break? That's 1 hour, basically. Take a short 5-minute break, and we'll come back. Crewton Ramone's House of Math.com for more.